Okay, so the second talk is also a very fundamental problem that you have when you have these modular IoT spaces, and it's about giving IoT services an identity and changeable attributes. And so this goes into the security direction. This is about when you have these services, they're getting developed somewhere, and then they're getting shipped first to a site, and then also to compute nodes. And we want to make sure that the components in between are not tampering the security properties that we have there, and that we can anonymously identify the services that we have running in there. Okay, so our setting is the following. So it's similar to the app ecosystem that you have for smartphones. So you have distributed developers, then you have one or multiple app stores that use as distribution system for the applications, and then you have multiple IoT spaces that could be running site locally, but as I said before, they could also be a combination between something in the cloud and something that is running locally, for instance, or they could also be fully running in the cloud. So there are no limitations with the solutions for that. The reason why we go site locally is basically privacy, because then we can make sure that the data is not escaping from there. Okay, so why do we want to do it? So we want to fulfill or to reach the following goals. So we want to identify the belonging of a service to one system, because when you have these IoT services running on distributed nodes within one site, you do not necessarily know that they actually were installed to the site, and therefore it's important that you can cryptographically identify their belonging to the site. Then we want to validate the intermediate processing, so what happened on the way from the developer to the compute node, and then we want to have secured metadata in there. Okay, so the solution enables certain properties. So it enables securing the service integrity and the metadata integrity. It enables authenticating developers. It enables authenticating the store and validating its operation. It enables providing services with a cryptographic identifier. And it enables ensuring or checking if a service belongs to an IoT site or not. Okay, good. And last not least, okay, there are 2 points. So this is also a very important property here. So we want to be able to do dynamic changes on the service metadata. So there you can think of, for instance, some access restrictions that you want to change at runtime within your site, and there's a little bit challenging to distribute the changes on the distributed nodes that you have running there. And we want to have the system running in a fully distributed manner. The idea there is when you have an IoT system, it might be that links are breaking down, and still your different compute nodes should be able to identify that a service was actually installed to the site by an authorized person. Okay. Good. And so this is the network connectivity disruption, so we want to be secure also if we have disruptions in there. Okay, so coming to a more technical point of view, so here you see the middleware again with the data nodes and the trees here, and here you see the life cycle. So we have a developer here. The developer is creating an executable. It's creating some metadata here. In our case, it's also creating this data model here, and then it's uploading the entire thing to the global store. And then from the global store, you can install the services to your local site. The vision there is that you have an interface similar to your smartphone, so you can use your tablet, for instance. You have a service management head in here, so on Friday I will talk a little bit about the service management. You have a head here, and you can tell this head install the service. The head will then do some service placement decisions, will put it then on a compute node, and then it will be running here, and then we have nice things to do like updating, as we also heard before is also an important problem here. Okay, so this is our setting. So we have this service package here, and we want to ship it up to here, and we want to make sure that this one is not messing up with the properties, that we can still know who developed it, and that in here we can do changes to the metadata, plus we can also authenticate that the service was actually installed here. Okay, so how do we do that? So we install different things. So first of all, we install 2 certificate authorities. So we install one at the store here. So this will be our trust anchor that is global. And we install another one which is site local. Okay. And what we also do is we give all participants here a private key that can be used to sign certificates, because our solution is, as you guessed here already, based on certificates. And then we introduce lots of certificates here, and inside the certificates, so we use normal X509 version 3 certificates, because there you can add extended fields, and we add 3 fields at the moment. So we add a hash over the binary, we add a hash over the metadata, so about these two, and we add additional metadata. Okay, so why do we add the hash over the binary? Because we want to pin the certificate to the specific executable that we want to secure there. And this is what we can do by putting the hash of the binary here. Plus we want to ensure that the integrity of the binary was not violated by anyone here in between, because you could have attackers everywhere in this scenario. The hash over the metadata, because we want to secure the metadata. So there we have, in our case, information about this data model that is used. We could have information about access control and so on. And then we have additional metadata directly in the certificate. And the reason is that what we want to do is we do not want to change these 2 hashes here on the way from the developer to the compute node, because if we do not change them, we can validate that nothing was changed in this data here. And so instead, if we have metadata that should be changed, in our case this is the access controls, the access control groups here, then we put it directly in the certificate, because then you can change it when you create a new certificate by still maintaining the integrity of the other 2 hashes. Okay, good. So yeah, what do we do now? So first of all, the developer creates again what he created before. Then the developer is creating these hashes here and putting a certificate, and the certificate is signed with the developer's private key. Then the developer is uploading this to the store. The developer is registered to the store already, so the store has the public key. So the store can then validate that the package was actually coming from the developer here. Then, why do we need the store here to have another certificate authority? Because we do not want to configure all the developer's public keys in the distributed sites here, and therefore we use the store as the trust anchor that we have in there. And then here the store is doing nothing else but copying the certificate and signing the copied certificate with its own key here. So this one, and for this private key, the local sites have the public key, because these are the associated stores. And then the entire thing is shipped here. Here, the user who's installing applications can do changes, for instance, on the access control metadata. So there you can imagine, like you have on your smartphone, where you can say you can access location and so on. So we have a similar access control scheme there. So the user can do changes there. And then happens the most interesting step for me, namely we create a new site local certificate. And this uses the site local private key here for signing. And this is the mandatory certificate that is used within one site. And then the entire package is shipped to the distributed nodes here. And as they know the public key of their local site, they can, whenever they receive such a package, they can identify if the package was installed in the site or if it was just coming in through a site channel. Okay, so this is a very, very important property. And what we see here is that in case we are not limited in storage, what we do is we carry all 3 certificates, because this enables the property that we can check if there was tampering in between. So best, we have the certificate of the developer here, so then end of the store, also at the node, because then we can do full validation of all the 3 certificates. But even if we don't have it, we can still check if the certificates are valid and if the data was changed in between or not. And so this is then helping us to also validate the operation of especially of the store in between here. And so you can also do it, of course, here. You can check when you have the certificate of the public key of this one here, you can check if the store did something malicious or not. Okay, good. Another very important property is, so this is a very old idea, so Rivest was showing that in 1998 already, there's a paper about that. We use short lifetime certificates. Okay, so this does not scale for the big internet, but it scales for our setting here because we are within one administrative domain here only. And so why do we use short lifetime certificates? Because when you think about these are access decisions, then it might be that at runtime you want to change the access decisions for your applications. And if you have a system where the links may fail, then you want to make sure that your new access permissions are distributed to the nodes as soon as possible. But if there's disruption, you cannot ensure that. And what we do now is that we have these short lifetime certificates. So at the moment we use approximately 1 day because this was a good trade-off between having renewal traffic and having the security properties we want to have. And if you do a change here, we can then guarantee that at max, the certificate lifetime, the properties will be updated on all the nodes. And what happens practically? Well, if there's a change, this component tries to connect to the node local managers and then to update the certificate directly so that you have the new metadata directly pushed to the nodes. And if this is not possible, then the certificates here will be valid maximum 1 day. That means after 1 day, the entire services will go down. So this is good for the security, and it's bad for the availability of the system, of course. And therefore, you have to check which is the trade-off there. But our system enables to have the high security properties. Of course, you can leverage this by having longer certificate lifetimes in there. Okay, and so the constraint, of course, for enabling that is that you have roughly synchronized clocks. So they have to know when the certificates are expiring. And so you have to ensure that. But if you have that, as our components are controlling who can access what, then we can ensure this security property. Okay, so this is the paper from 1998 about eliminating revocation lists. So this is already about having these short lifetime certificates. And to summarize, so we secured service integrity and metadata integrity. We can authenticate developers, we can authenticate the store and validate its operation. We can provide services with cryptographic identifier, provide their belonging to an IoT site. We can do dynamic changes to the secured metadata, and we have a fully distributed authorization using these short lifetime certificates. One interesting measurement we did is that first we started all the services at the same time, and this is realistic when you think about a power outage inside your IoT system, and then all are running at the same time, and so obviously you have then high renewal traffic peaks. And if you just introduce a random factor, which is a quite simple solution, but as you see, it's quite effective, because then you have a more distributed traffic, and so you don't have that strong peaks then anymore with the renewal traffic in there. We also looked at the energy consumption, and so the basic result of this one here is that whenever you have renewal, then you have a peak in the energy consumption, and so this is of course also something to consider depending on which are the properties of your system. So we are more looking at powerful nodes like Raspberry Pis, for instance, and they are typically not battery powered, and therefore this is not a huge issue for us, but we still wanted to look at it, which is the impact of such a solution. Okay, that brings me to the end. Thank you very much. I'm looking forward to your questions.
Thank you.
Yeah, the certificate thingy and the authentication thingy, it's actually the basic security aspects.
Yeah.
So my question is that why haven't it been implemented before? Like, what is the previous literature, and what are you bringing new on the table? Because I don't follow it exactly, because the thing is, yeah, IoT is for like last decade. And why haven't people implemented this before? Like, is it for that there are lots of IoT devices, and if you do this kind of certificate thingy, everything gets blocked, or things make more complicated, or what was the thing before? What is the main motivation behind it now for you?
Mm-hmm. So very good question. So why was it not implemented before? So the key problem in the IoT to me today is that it's still these silos. So you have the vendor silos, and the devices are just not having a common runtime system. So I'm not aware of ecosystems where you are able to install applications inside the network at the moment. So this is just it's a very straightforward solution, but at the same time, at the moment, there is no ecosystem that allows you to do such a thing, and therefore It's a very fundamental property that we wanted to make sure that we have something where we can rely to, where we say, okay, so this is how you can do it, and then on top of that you can do interesting things like access control, because as long as you don't have an identity of the services and no means to have secure attributes that you can put to the services, then you can do no additional security properties. So the answer is basically, it's the scattered ecosystem, so you have too many players and they are just not having one standard. And this is at the same time the reason why this solution, to adopt it, you would need all the vendors to agree on, so this is our certificate format and this is how we contain our services and so on. And so I do not see this happening at the moment. I would not know which player would do that.
Yeah, that's very nice.
Thank you.
Question? Nicolas?
Yes, so I had a question about again, the formal aspects of your architecture. So you detail yes, an interesting architecture with many different properties. And did you have an interest in protocol verification to validate, for instance, to validate that there is no attacks, for instance, an attacker that would push a certificate to a smartphone that would not be authenticated by the certificate authority?
So what we have in there is for all the communication channels that we use there, they are already TLS, so they are transport layer secured. And so this is how we somehow try to avoid man in the middles. If I understood your attack correctly, you would need to forge the site local certificate authority, because you would need to use the private key of the site local certificate authority.
Actually, my example of attack was one example, for instance, but it was more on the logic of the overall protocol terms. I'm not expert in this domain, but I know that for people working on this question in Riyadh, it is possible to formally specify the architecture and to state that it well satisfies the properties that we want to provide. And did you have an interest in such methods to validate your architecture?
So the answer is we definitely have an interest to do that. At the moment, we did not formally analyze it there, but what we do there is identical to what you do in the internet today with websites and certificate distribution there. And therefore, I would expect that it would also stand the formal validation, but I would definitely be interested in also going into that aspect. And so if this is something where you're knowledgeable, I would be very happy to collaborate with you in doing that, for instance, because it would make the approach even stronger, especially when targeting more security-related communities.
Okay. Thank you.
Thank you.
Okay, so this ends the session. Thanks again, Mark Oliver and all the speakers of the session.
Thank you.